Welcome to this video regarding paint film thickness and using a mil thickness gauge, where we'll discuss why paint film thickness is important, the different ways to measure it, and some other considerations that are also important regarding the thickness of paint. Paint and primer coatings are measured in mils, which are 1/1000th of an inch thick, and that's equivalent to 0.0254 millimeters. We need to refer to the technical data sheet for whichever product you're applying to determine how thick the product needs to be applied. Typically, these are referred to as dry film thickness. In addition to the recommendation for the thickness of a specific product, we also must consider the overall thickness of the completed job. If you are applying multiple products, how thick will they be once they are finished and dried? Further, are you applying your paint on top of existing paint? And so there's a recommendation of a maximum of 12 to 14 mils total for the entire paint jobs and whatever's underneath it. And that is to ensure the best quality, to ensure the paint will last without failing. If the mill build exceeds that 12 to 14 millimeter range, the suggestion at that point is then to strip down to a sound substrate, typically the metal or composite material below, which may also have previous repairs in it as seen in this image. Before we continue with our application, we always want to make sure that the paint is mixed appropriately. And one of the measurements that we do is called viscosity. Viscosity is a material's resistance to flow, and we use a viscosity cup as seen here, dipped into liquid and then timed. The amount of time it takes to have the liquid come out and then start to sputter, as we see in this moment, is the viscosity. And if it's the correct viscosity, the product should be applied correctly as per the TDS sheet, which should give us the appropriate mill build, along with ensuring that the panel and the paint are at the appropriate temperature and the paint gun has the correct settings, including the tip size and air pressure. Paint film is typically measured once it's dry, but using a tool like this, it can be measured while it's still wet. On the back side of this gauge, you'll see some other measurements that include microns. Microns are a measurement that we don't typically use in North America, as we typically revert back to the mil measurement referring to 1/1000th of an inch. To use this tool, we apply whatever coating we're spraying, in this case a primer surfacer, to our panel. And then what we do is on the edge of the panel, where we are not going to damage whatever it is that we're spraying, we insert the gauge into the wet product. What this will do is leave a mark noting how thick the paint is. Essentially what happens is each of the little edges on the side of the gauge are longer than the others by 1 or 2 mils. And as we insert this, we'll see marks or we won't see marks. If there's a mark in there, then that means that the coating has reached that level. So we look at the next one and we look until we don't see any marks anymore, and then look at the number that corresponds to, which tells us the thickness of the material. So if we have a look at this image here, we will see that when we insert it, it leaves those marks. And if you notice in this one, the 11 is touching and then the 12 is barely touching, telling us that this is 12 mils wet. If we go up to the 14 and higher, it does not leave any mark in the panel. So we would say that this one is 12 mils while wet. Dry, however, it's been measured at 9.8 because the solvents do evaporate, leaving a different film thickness. A digital mil thickness gauge like this one can be used to measure the film thickness of dried paint by placing the end of the tool, the probe, directly on the dried paint. And this uses magnetism to read the thickness of the material. You'll notice that the thickness varies across this panel because it has had repair in one area, which has body filler, and then there's other areas that have primer surfacer and multiple layers of paint. This tool will not read on anything other than ferrous metals such as steel. So, when we need to measure paint thickness on non-ferrous panels such as this bumper cover or aluminum and other plastics and composites, we can use this type of mil thickness gauge that uses ultrasonic technology. This tool is able to read through the paint and determine where the substrate is and give us a very accurate reading, very similar to ultrasound using this gel. We can see this bumper has had some repairs done in it before, and it's also had some wet sanding and polishing, which has reduced the mil thickness in a few areas. When working with bumper covers such as this, we also need to be aware of any potential sensors behind the bumper cover. Therefore, it is important to research the OEM information for the vehicle you're working on and see what the recommendations are. For this particular recommendation seen above, General Motors does not recommend exceeding 13 mils, including any repair material. Otherwise, the panel may need to be stripped or replaced. Other manufacturers note that certain products in the paint, such as metallic pigments, can also affect the way the sensors read, and therefore this also goes into the concern of mil thickness. Other manufacturers may not allow any additional paint jobs to be performed over top of the bumpers, or in some cases, parking sensors that need to be painted as well. Always refer back to the OEM procedures and consider any potential concerns, especially regarding safety regarding paint film thickness. Thank you.